Hi, good day. Good day from wherever you might be joining us, and thank you for joining. Thank you for joining our talk about spatial analytics at scale. I just wanted to introduce myself real quick. My name is Brian Suk, and I'm based out of New York City. You can follow me on Twitter there if you so are inclined to. And I am currently at google.org working with the Morehouse School of Medicine. We are tracking the political determinants of health with respect to COVID-19, and I'm a data engineer on that team.
And hey everybody, I'm Julie Price. I'm a data architect actually on the gaming industry's team, but have been working in the data space for a really long time, and love any opportunity that I have to pair up with Brian and start to use our data for good.
Thanks. So we did want to show you a couple new things that are coming down the pipeline, but we did want to just give a brief glimpse into some of the broader tool set that we do bring to bear when we start thinking about some interesting use cases for spatial analysis at scale. And did just want to take a couple seconds and talk about the core component of the technology stack that we're mainly using. And BigQuery is really at the crux of all this. And one of the really cool things about it is that it is a completely serverless, totally fully managed service for data analytics at scale. And so the really cool thing about it is you can essentially just load your data into it. It will automatically store it, manage it, encrypt it, and so on and so forth. And if you know how to use SQL, you can just immediately start querying that data as soon as it gets there. There's no management of infrastructure. You don't have to think about servers or hard disks or networks or anything like that. You can kind of think of it like petabyte scale data analytics, but sort of like the Gmail version of that, where you're not really installing anything. You just kind of point to a URL and you go. What we've been doing here on the Google team over the past few years is we've been expanding the feature capability sets of that. So in addition to core data analytics and standard SQL queries that we're all kind of used to and we're all familiar with, we've also been adding things like machine learning capabilities, and more importantly and more relevant to this discussion, we've also been adding geospatial capabilities as well. And so if you're familiar with ST transformations and constructors and ST functions and things like PostGIS, it is essentially the same thing, and the syntax will be fairly familiar. So if you do have any level of familiarity with those tool sets, then you are immediately able to use something like this as well. This is part of the broader data platform, in which it does include things of the broader Google Cloud platform, as well as things like Google Earth Engine for raster data and raster processing of imagery data. But in addition to some data sets that we do provide, and satellite data sets and vector data sets, the BigQuery part of it is really a key component of this broader platform when we're trying to put together different solutions to tackle different problems, depending on what you're looking for. But what's really cool that's currently in beta that we really wanted to focus on is what CARTO's been building. So CARTO has built a really interesting tiler capability that's been built directly into the BigQuery engine, and so you can call this functionality directly within BigQuery itself. And so now what's really neat about it is if we're looking at data sets at scale, so if we're looking at hundreds of millions, billions, and multiple billions of rows, and we're trying to visualize that, one of the common problems that we have in mapping technologies is that you're not really going to be looking to load hundreds of billions of rows necessarily into a particular visualization all at once, because when you try to render that, it's going to struggle with it. And so this idea of zoomed out tiles and layer-based visualizations is very common to solve this problem. So Google Maps itself is one example that I can think of, where you zoom out, you see a certain level of aggregation, but then it constantly zooms in and you see layer by layer how that sort of enhances in. And one of the neat things is we can now construct MVT tiles using the scalability of the BigQuery engine and not have to sort of farm this out to different servers and different applications and do this right into the engine, which is really, really neat. And that's kind of what we want to show you in the next few steps. So I'm going to switch over to my application window. I really just want to show you what this interface looks like. Let me zoom in one step. Maybe a little bit too much. There we go. And I want to show you what this actually looks like in action. And so, especially on the project that I'm working on, it's kind of come to light that when we're looking at any sort of analysis and we're trying to visualize things, mapping is really going to be a core component of it. And so one of the things that we kind of wanted to show an example of this is looking at the OpenStreetMaps data set and seeing if we can sort of visualize this entire data set all at once. And so what you're looking at here is the BigQuery interface in essence. And so this is one of the ways that you can access it. And this is probably the first way that most people will access it. But as you can see here, it's pretty much just a SQL interface, right? So if you're familiar with writing SQL queries at all, you'll probably feel immediately at home here. And one of the things I wanted to show, first of all, is the geospatial capabilities. And so what I'm telling this to do here is quite simply to just take the centroid of the geometry of, the geography. I know it says geometry, but these are actually geography features, and we have a bad habit of mislabeling data columns here. But this is actually taking the centroid of all the different buildings, because we're looking at the tags here and filtering out for just things that are buildings, and we're asking it to just take the centroid of that particular building and process that, and then just expose that out. So now we're looking at individual point geographies instead of the polygons in the buildings. And so if we run that, now we're looking at the different columns in the data table in the OpenStreetMaps data set. But now we have a geography type of point instead of the polygon, which is just kind of the center of each individual building. Right now, I'm just limiting it to 20 rows because I'm not looking to bring back the entire data set at this point. But what I have done before is I actually have gone ahead and I've run this, taking out the restriction of the 20-row limitation, and I wanted it to process the entire data set. And so what's more interesting here is the fact that we've been able to process this entire data set, and the output of it is a new table that we have here in our new data set. But not only is it only taking about 5 minutes to geoprocess the entire OpenStreetMaps data set, which is roughly about 400 million data points. The original data set's about 800 million data points, and the resultant is about 400. But we're doing this all without any infrastructure management whatsoever. And so I'm thinking about the workflow that I would typically have if I want to stand up like a Postgres database. I have to stand up the virtual machines, install the software, make sure it's all patched up. And then I'm worrying about security, networks, hard disks, and also managing the cost of all that. But instead here, I can simply just point a query to a table and hit go, and it manages all that. All that management of infrastructure sort of goes away to some extent, right? And so the benefit that I have as an end user trying to implement projects is the fact that all that time spent managing all the tooling has been drastically simplified and been drastically reduced. And so I can get to my insights very, very quickly. And the resultant data set, when we process the whole thing, it'll look much like the previous query that we output. But now we have 417 million rows of data that we have in this particular data set. Now, one of the things that we also have done is you're probably asking where this data set comes from, and this is from the OpenStreetMaps data set, which comes from a table called Planet Features, and this is a 800 million row table that is part of the public datasets program here at Google Cloud, which is a set of free and open datasets that we curate, maintain the data ingestion and integration pipelines for you, and provide free of charge. And so the actual storage costs are things that we incur and we manage for you. And if you go to the marketplace, there are a number of different data sets ranging from COVID-19 data sets to Bitcoin data sets to US Census, Bureau of Labor Statistics. There's a number of different data sets that we provide for you that you have access to as well. Now, what I also want to go to is the actual tiler, because this is how we start to visualize things. And so what you've been looking at so far are actually functionality of BigQuery itself. So you're looking at the spatial type processing that BigQuery can do at scale, all fully managed for you. But this, where the CARTO Tiler functionality comes in, is being able to take geodata like the data set that we just showed in the OpenStreetMaps, and we can now process that to create MVT tile sets. And so what you're looking at here is the actual call to the function, the CARTO function that processes your data, and it will create that resultant tile set for you. So very briefly, just want to walk through what this is doing here. This is probably the most basic form of creation call that you can do. And it comes in three main parts. And so the beginning here, the first component of it is quite simply pointing this particular processing to your source data. So here I'm telling it the particular column with the centroid points of the buildings in the buildings data set that we created. The second component is quite simply telling it where I want to store my tile set. And the third component are resultant columns that you want to create. So in this particular one, I am telling it to just count the number of objects within a certain zoom level, and then store that metadata within the tile set. And so when I run that, you end up with a tile set, a resultant tile set that looks like this, where you have some metadata that visualization tools can go and use, which actually CARTO does provide one. So there's a number of different ways you can access this, whether it's, hey, I have some analytics tool that I'm familiar with. Can I link it to BigQuery and process it? Yes, you can. I have some sort of statistical analysis program, or I want to load my data sets into CARTO Builder, or I want to load it into a CARTO frame, or I want to use it in a Python data frame, or so on and so forth. Yes, you can. If you have a CARTO BQ tile set and you quickly want to visualize that, one of the many methods of being able to just quickly look at that information is the online viewer from CARTO. And this is actually pointing to the Planet Features buildings tile set that I created. And right now it's just showing it at a high zoom level. So now I can just kind of see. But as we start drilling in and we start zooming in, we're looking at hundreds of millions of rows that are represented, but it's easily able to redraw this at different zoom levels, because now we're optimizing for the different zoom levels that we're at, and it can quickly return that data. So that way we're zooming around and we're not waiting for a lot of processing to come back necessarily. And so this is probably what I would say is more of like a hello world of both BigQuery geospatial as well as the BigQuery tiler that CARTO has implemented. And at this point, I would like to hand it off to Julie for a different use case leveraging all these different technologies.
Thanks, Brian. So what we wanted to do now was take the scale down a little bit and start looking at a couple of different data sets and start looking at a few more advanced features within BigQuery Geospatial and how we can kind of operationalize some of this into various different things. So one of the things that's really close to mind for me right now, I actually live in the Northwest Denver area. Like Oregon and Washington and California had earlier, we are actually being kind of ravaged by fires right now and smoke quite frequently. And so one of the things that I thought would be really interesting to look into would be just looking at fires and the areas that the fires are consuming and the air quality that is close by. And so we do all of this using the same capabilities and the same technology that Brian was using, but in a little bit different way. So first, let me go ahead and share my window. There we go. So what we want to look at first is the data. First things first, we need to understand the perimeters of the fires, how big they are, and we also need to understand the air quality. So we want to be able to bring these two different data sets together. So we have a data set that comes from the National Incident Feature Service, which is just giving us the fire information, the perimeters of the fire, the geography of the fire, incident name, some other interesting information, all in a single table. And it's actually not got that many rows, which is good because it's 1 row per fire, although 1,300 fires is quite a few that are going on in the country right now. And if we look at the data, we can see that what we end up having is essentially the polygon information, and this can be multi-polygon or single polygons, for the various different fires that are occurring, along with all of that other information, the incident name, the acreage, and so forth in BigQuery. We can preview this data quickly, easily, and for free in BigQuery, which is great. Now, the other piece of information that we want to bring in is actually the air quality. And so we've got a data set where we're streaming in from OpenAQ the air quality indexes into a table, and we're pulling in information about the coordinates of where the actual readings are being taken, the averaging period, and so forth. So we're looking at some average numbers over periods of time so that we can pull that information in. So having these two different data sets, we want to be able to join them together so we can get meaningful information. We're not really looking to process every single air quality across the country. We really want to look at what's close to fires. So what we want to be able to do is join this data together and say, show me all of the readings that are within a certain distance of the centroid of each of these fire polygons. So in BigQuery, just in standard SQL, we can write a query that looks like this. I'm going to go ahead and start to run it. And by the way, we have about 90 million records in the air quality index. So we'll walk through this query really quickly while it's running. Okay, and actually, let me just do something really quickly because that ran with cached results. I want to show you how long it takes, not with cached results. So, but that is really cool that if you've already run this query, you see how quickly it runs, literally in a millisecond, in milliseconds. But okay, so let's start over. Now, first things first, we want to get the perimeters of the fires. We want to understand what the geography is of the fires. So this first subquery that we're doing is just selecting the fire geography along with the incident name, object ID, and create date. So we're creating that, we're just pulling that fire polygon. And now what we want to be able to return is the actual geographic points of the latitude and longitude from each of the measurements that we're getting that are close to those fires. So we're continuing to use further native capabilities, but in standard SQL. And if we go down to the join, this is where the real magic happens, where we can actually join the data using an std within. So we're looking for any of those geographic points where the air quality indexes were being pulled that are within 120 kilometers of the centroid of the fire polygon. And so we did this all with standard SQL. As Brian mentioned, we're doing this all with infrastructure you don't have to worry about. You don't have to worry about the scaling of it or anything like that. And what's great now is that by being able to join this data together, we're able to bring together both the fire perimeters and the polygons along with those air quality indexes as well. Now you can see this came back in 1 minute and 13 seconds. Returning quite a few rows of data. It looks like about 4 million rows of data so that we have all of these various different points that we can use in a calculation. All of this can then get fed into the BigQuery Tiler that Brian showed you earlier from CARTO. So what we're going to do here is just call the BigQuery Tiler to get the point aggregation as a map box vector tile. So then we can start to layer that into our maps. Now we've already run this, but you can see it's the exact same query. And all of that it's doing is going to output the vector that's going to bring all of those points together so that we can layer those on a map and be able to really smoothly be able to zoom in, zoom out, and everything that Brian showed you. So now if we wanted to operationalize this and say build maybe like an HTML representation of this and embed it into a website so that we can see in real time as this information is coming in, how the air quality is next to all of those fires. We can build a simple HTML file which has a lot of information in it. What we're doing, if I just zoom up really quickly, we're actually bringing in from Google Maps the map background, and we're specifying where we want to zoom, we're specifying how we want it to look. But what really is interesting here is the way that we actually get the layers. So first, as I mentioned, the BigQuery Tiler, it's outputting an MVT compatible vector. And so all we're doing here is assigning the Tiler information. These are just the endpoints where the BigQuery information lives from the CARTO Tiler. We're assigning that to the MVT layer. We're giving it an array of colors so that we can see how severe the actual air quality is, and you know, what the pixel points are going to look like. And then we're bringing in the data using the CARTO SQL layer. So we're able to write just a SQL query where we're pulling the polygon information for the fires. And ultimately what we get is this really nice map where we can see alongside each other all of the different fires in purple, so you can see the exact shapes of them. This here is the Cameron Peak fire. It's actually the biggest in Colorado state history. And this one up here is actually the second biggest in Colorado state history. But as we zoom in, you can see really smoothly, we can immediately see the effects on the air quality for the fires that are actively running. We can see that these fires are all affecting the air quality in Denver, even though they're not necessarily that close, all the way up to Longmont. And for those of you who might be on the West Coast, of course, we see quite a few fires and a lot more poor air quality indexes. So it's really nice to be able to pull all this information together without worrying about infrastructure, without worrying about scaling. We can scale, you know, essentially to any. I think we've run these type of queries on 29 billion points before, and folks didn't have to worry about infrastructure or creating, you know, additional nodes of their geospatial database or exporting that data into any other type of system. So with that, I know that we're getting close to the end of our time. So just wanted to leave you with a couple of things before we open it up for questions. So first of all, we want to give you the opportunity to actually give this a try yourself. So we do have a booth where you can go and talk to folks and learn a little bit more about what we're doing with geospatial and BigQuery. We'll have a GitHub repo, which will be fully populated with all of the logic within the next couple of days. And we've left some links so that you can learn more about BigQuery Geospatial and join the CARTO BigQuery Tiler beta so that you can do all of these great things. So with that, I wanted to close and I think open up for questions. And so Brian, I think we had some questions in along to the side if we wanted to look through those and see.
Yeah, there was a question about different data types as well, and so there is a roadmap to aggressively add additional data type support. That's probably something on a roadmap that I would probably defer to the actual CARTO team themselves, but there will be additional data types coming in as well. Can you share the BigQuery GIS link in the chat window? Yes.
Yep, so let's share it out. I think there was another question on BigQuery integration with Earth Engine.
Yeah, sorry. And yeah, it looks like we can talk about it. Yeah, so the next week there will be an announcement from CARTO that for the BigQuery Tiler there will be additional support for polygons and lines as well. So in the near term, those are the things that will be added in addition to, you know, things that are probably, things that are part of the broader roadmap as well. And then, are there any other questions? Oh, thank you. These are our favorite hoodies. So we wear them to conferences as much as we possibly can.
Yes. And just wanted to mention also, if there's any questions, we left our Twitter handles. Oh, actually, there's a question on BigQuery and Earth engine integration?
Yeah, so right now, the primary way is primarily just exporting and importing vector data between the two. There is right now it's not directly integrated, as in like you can call one function from the other, but easing that pain is something that's being actively explored, but we don't have anything to announce at this time.
And then I think the final question was whether or not Google Maps layers are available in BigQuery public data sets, similar to what OSM is available right now.
So the actual information with the actual data being stored within Google Maps right now is something you can query through the API. Whether it's going to be stored as a BigQuery data set like OSM right now, it's still something that's under discussion.
Yep, and I think one more question is how long will the BigQuery with OSM integration be freely available? I'm not sure that we can necessarily answer that, but it is being made available as a public data set. They're feeding that information in. So as long as OpenStreetMaps is willing to provide us with that information, it will be there.
With regards to, sorry, when I mentioned the API for Google Maps, I was talking about the actual Google Maps API, which we can drop a link into as well with documentation on that. Raster data is something that we do have raster data libraries in Google Earth Engine, and so that's actually more suited for processing that kind of data. And so there are petabytes of data offered within there that you can go ahead and analyze within Earth Engine, and then you can import, export all about that. Okay, gotcha. And sorry, the last one before, it looks like we're over time. So the last one about costs, that is also something that we will further delve into in the GitHub repo and the leave behind. But yeah, there are on-demand costing for storage and querying of data. And so the cost mechanism is a little bit different because we're not charging you for servers and nodes or anything like that. But we will definitely leave more information on that too.
And just to wrap up, you can reach either of us at our Twitter handles, which were on the first slide, and we can leave them in the chat as well. And we'll leave behind all of the various different links for you so that you can give this a try yourselves. Thanks so much for your time today.
Thank you.